everybody. Couple of reminders of our schedule for the week. Tomorrow we are working on our review sheet. As our Ed Puzzle tomorrow, the Ed Puzzle's not going to be about the review sheet. Instead, the Ed Puzzle is going to be about how to access Friday's quiz and how I'm going to have you show your work. So I need you to do that Ed Puzzle so I know you understand how to do the quiz before I assign it. Then you're going to be working on your review sheet, and I'm going to post explanations for the questions on Google Classroom. And like always, your review sheet is going to be due on Padlet at 9 p.m., just like the rest of our classwork is. Okay, so let's take a look at this do now. I think this is a really great do now as we're leading up for Friday's quiz. Hint, hint, wink, wink, this style of problem. So we have that the diameter of the large circle is 24 centimeters. Find the shaded area in terms of pi. And I wrote pi, P-I, because I was having trouble accessing the pi button on the computer. So that's an acceptable way to do it if we're typing. Okay, so we've got our large circle. Diameter is 24. So our large circle, we know the diameter is 24, so all the way across. If the diameter is 24, that means our radius would be 12. And if we notice, the diameter of our large circle spans the diameter of 3 of the small circles. So the diameter of the small circle would be 24 divided by 3, or 8. Okay? Which means the radius of the small circle would be 4. Okay? So to find the shaded area, we're going to do our large circle minus our 3 small circles. So let's start by finding the area of our large circle. We're going to do area equals pi r squared. Okay. We said the radius was 12. So 12 squared is 144. So our area, 144 pi. And let's leave that in terms of pi for as long as possible. Okay, now let's find our small circle, our one small circle. Area is pi r squared. The radius is 4. 4 squared is 16, so 16 pi. Right, so now to find our shaded area, we're going to do our large circle minus our 3 small circles. So that'll be 144 pi minus 3 times 16 pi. So let's simplify. 3 times 16 pi is going to be 48 pi. And then we're going to subtract. So 144 pi minus 48 pi. We can do that subtraction because they're like terms. They're both in terms of pi. Is going to give us 96 pi. And we're leaving in terms of pi. So we just need units. Centimeters squared. 96 pi centimeters squared. Today we're going to work on pages 28 and 29 in our booklet. Both pages need to be uploaded to Padlet. Today was kind of designed as sort of a practice applying our applications of area and perimeter. We're going to still follow through with that. There's a couple of questions I want to go over with you just to give you a little bit of a nudge in the right direction. Number 1 here, I think these ones you guys can handle, finding the shaded area. I wanted to go over number 2 with you. It's a nice problem. We're talking about a rhombus and an equilateral triangle and perimeter, and there's an unknown. It's good stuff. So let's do that one together. A side of a rhombus is 5 less than twice the side of an equilateral triangle. The perimeter of the rhombus is the same as the perimeter of the equilateral triangle. Find the length of the side of the equilateral triangle. And I gave you a reminder that in a rhombus, all sides are congruent. Okay, so we're finding the length of the side of the equilateral triangle. That's our unknown. I'm going to say let x equal side of triangle. Okay, and if it's an equilateral triangle, I'm going to draw myself a little picture here, right? We know all 3 sides are equal, so then all 3 sides have a side length of x. Okay, we also have a rhombus. The side of the rhombus is 5 less than twice the side of the equilateral triangle. So we want to translate that to algebra. 5 less than twice the side of the equilateral triangle. Remember, less than, switch the order, is going to be 2x minus 5. That's our side of our rhombus. And let me see if I can sketch a picture of a rhombus here. That wasn't too bad. Not bad at all. And the rhombus, all 4 sides are equal also, because it's kind of that square that's kind of pushed over. So all 4 of those sides are going to be 2x minus 5. Okay. Now, information for our equation is that the perimeter of the rhombus is the same as the perimeter of the triangle. So let's make our equation, and we'll do perimeter of our rhombus. Ooh, I spelled rhombus wrong. Rhombus is the same as, is equal to the perimeter of our triangle. Okay. So our rhombus, the 4 sides are equal, so the perimeter is going to be 4 times 2x minus 5, or you add it up 4 times. Perimeter of our triangle, x plus x plus x, or 3 times x, 3x. Now let's just solve for x. So we'll distribute. 8x minus 20 equals 3x. Now we're solving for x. Remember, variable side is going to be on the right, right? We have that variable term isolated. It's like that lone explorer that went out and claimed it Variabletopia. So we'll subtract 8x from both sides. Negative 20 equals negative 5x. Let's divide both sides by negative 5. And we get 4 is equal to x. So we weren't given any units here, so I'm going to say 4 units is our answer there. The other question I want to go over is number 3 on page 29. What is the area of the largest circle that will fit inside a square with an area of 64 centimeters squared? Leave answer in terms of pi. And a circle inside of a square, I'm really kind of thinking of this image here as my guide of what's happening. So if I'm thinking of a sketch, right, we've got a square, and then inside, the largest circle that'll fit inside a square, it's going to touch all those sides like we saw on number 1 on the previous page. And we were able to figure out the relationship between the side of the square and the diameter of the circle being the same. So that's kind of what I want to use here. Figure out that side length so I can figure out the diameter of the circle and then its radius and find the area. So area of a square I know is side squared. We're told the area is 64. So 64 is equal to s squared. And some of you might just see this, but I'm going to show the work. Let's take the square root of both sides, and 8 is equal to our side length. So our side length is 8 centimeters, which then tells us that the diameter of the circle is 8 centimeters. So the radius must be 4 centimeters. Now we can find the area of the circle. And woo, we get to leave it in terms of pi. So radius is 4. 4 squared is 16. So that would be 16 pi centimeters squared. Okay. The rest of these problems, numbers 4, 5, and 6, you really just kind of have to make examples and test them out. So it might take you a little time, a couple of tries, but it's all right there for you. Okay, so once again, we're going to post this on Padlet. You should also be working on the review sheet that's posted to Google Classroom and in our weekly outline. Want to be working on that and thinking about any questions you have of any content we've already covered. All right, have a great day. And a little math joke to finish off the day. Here's today's. I like this one. What did 2 say to the other prime numbers? I'm glad one of us is even-tempered. Broomch.